Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're measuring the gap between current AI systems and human intelligence, taking a journey through today's most compelling AI research frontiers. We'll examine how computer science artificial intelligence research is tackling the challenge of moving from narrow expertise to true general intelligence, synthesizing discoveries from leading laboratories worldwide. Picture this fascinating paradox. A toddler effortlessly recognizes their favorite toy among dozens of others, then seamlessly switches to building an elaborate block tower while carrying on a conversation about dinosaurs. Meanwhile, the most advanced AI system in the world can write poetry, solve complex math problems, and analyze satellite imagery, yet struggles to remember what happened 5 minutes ago, or fails completely when asked to identify a simple melody. These systems excel remarkably in some domains, while revealing glaring blind spots in others. This contradiction highlights why cognitive flexibility remains one of the most elusive challenges for artificial intelligence, despite tremendous advances in specialized capabilities. Welcome to this journey through compelling discoveries emerging from the world's leading AI laboratories. Today we'll uncover why our smartest machines still cannot match a child's cognitive flexibility, explore how AI is revolutionizing everything from medical diagnosis to Olympic sports officiating, and discover what these breakthrough advances mean for our shared future with artificial intelligence. We'll examine both the theoretical foundations that drive this research and the practical applications that are already transforming industries. From understanding the fundamental nature of intelligence to deploying systems that can work alongside humans in complex real-world environments, this exploration will reveal the current state and future trajectory of artificial intelligence research. Think of the field of artificial intelligence research as a vast archipelago of interconnected islands, each representing a different aspect of intelligence. Some islands, like language processing and image recognition, have been extensively explored and developed, featuring towering cities of sophisticated algorithms and impressive capabilities. These territories showcase remarkable achievements in natural language understanding, computer vision, and pattern recognition. Other islands remain largely uncharted territory, shrouded in the mist of unsolved problems and fundamental questions about the nature of intelligence itself. Computer science artificial intelligence, or CSAI as researchers call it, serves as the main shipping route connecting these diverse islands. This interdisciplinary field draws insights from neuroscience, psychology, mathematics, and philosophy, creating rich connections across the cognitive sciences. The first major theme emerging from current research is what we call the cognitive completeness challenge, the quest to build AI systems with well-rounded intelligence rather than narrow expertise. Imagine trying to hire an employee who's brilliant at calculus, but cannot remember where they put their keys 5 minutes ago. That's essentially what we're dealing with in current AI systems. Recent research has developed sophisticated frameworks for measuring artificial general intelligence using the same cognitive assessment tools we use to understand human intelligence. The results are both encouraging and humbling. Even our most advanced systems achieve only 27 to 58% when evaluated comprehensively across the full spectrum of cognitive abilities. These systems exhibit what scientists call jagged cognitive profiles, excelling in knowledge-intensive tasks while showing critical deficits in foundational abilities like long-term memory storage. The second emerging theme revolves around explainable and trustworthy AI systems that move beyond black-box decision-making. Picture a doctor who gives you a prescription but cannot explain why they chose that particular medication. That's the challenge facing AI deployment in high-stakes environments. Researchers are making remarkable progress in creating AI systems that can not only make decisions, but also explain their reasoning in ways that humans can understand and trust. One particularly impressive example comes from Olympic sports officiating, where AI systems now help referees make split-second decisions while providing clear visual explanations of their recommendations. This breakthrough in transparency allows AI to serve as a collaborative partner rather than an opaque decision-maker, building trust through clear justifications for complex judgments in real-time scenarios. A third emerging theme focuses on privacy-preserving collaborative AI systems that can learn from distributed data without compromising sensitive information. Think of it like a group of hospitals wanting to collaborate on medical research without sharing patient records. New federated learning approaches allow AI systems to gain insights from data across multiple organizations while keeping the actual data secure and private. This breakthrough technology enables hospitals to collaborate on treatment protocols, pharmaceutical companies to develop drugs using broader datasets, and financial institutions to detect fraud patterns across networks, all while maintaining strict privacy protections. These advances are removing traditional barriers to AI adoption in regulated industries, opening doors for applications in healthcare, finance, and other sectors where privacy has historically prevented collaborative intelligence initiatives. What happens when researchers actually measure how close our smartest AI systems are to human-level intelligence? The findings might surprise you. The first concrete AGI measurement framework has been established, providing quantifiable criteria for assessing artificial general intelligence. Even advanced models like GPT-4 score only 27 to 58% overall, when evaluated comprehensively. These systems exhibit jagged cognitive profiles that reveal uneven capabilities, excelling in some areas while showing critical deficits in others. Long-term memory has emerged as a particularly critical weakness, highlighting fundamental architectural limitations in current approaches. However, benchmark purification research has revealed that many apparent AI failures might actually be artifacts of flawed testing procedures. When researchers cleaned up ambiguities and errors in established benchmarks, they discovered hidden AI potential, with smaller models achieving performance comparable to systems with 200 times more parameters. Today's paper of the day takes us into the fascinating intersection of artificial intelligence and human cognitive assessment. A definition of AGI by Dan Hendricks and his colleagues tackles one of the most fundamental questions in AI research. How do we actually define and measure artificial general intelligence? This work provides the first quantifiable criteria for artificial general intelligence, moving beyond philosophical arguments to empirical measurement. The researchers adapted the Cattell-Horn-Carroll theory, the most empirically validated model of human cognitive abilities, for AI assessment. This approach is grounded in decades of human cognitive research and addresses the field's critical need for honest capability evaluation, rather than marketing rhetoric. The methodology represents a paradigm shift from subjective assessments to rigorous, standardized measurement of AI capabilities across multiple cognitive domains. The AGI assessment methodology represents a careful adaptation from human psychology to AI evaluation. The researchers tested 10 core cognitive domains comprehensively, including reasoning, memory, perception, and processing speed. Psychological tests were carefully adapted for artificial systems, creating evaluation protocols that could assess artificial rather than biological intelligence. When applied to state-of-the-art systems, the results painted a nuanced picture. GPT-4 achieved only 27% overall AGI score, while more recent systems reached 58%. Significant progress, but still substantially limited. These numbers provide the first concrete quantification of both the rapid progress being made in AI development and the substantial gaps that remain. The assessment reveals both remarkable achievements in specific areas and fundamental limitations that prevent current systems from achieving more balanced, human-like intelligence. The implications of this AGI framework extend far beyond academic interest. By providing concrete targets, this research establishes clear objectives for AI development efforts and offers standardized methods for comparing different AI systems over time. This framework could influence funding decisions, research priorities, and public policy discussions about AI development. More importantly, it provides researchers with a roadmap for addressing specific cognitive limitations. The findings point toward the need for architectural innovations rather than simply scaling existing approaches. Long-term memory storage has been identified as a critical gap, suggesting that breakthrough advances in information retention and retrieval mechanisms may be more important than increasing model size. This research challenges the field to pursue fundamental advances in AI architecture, rather than relying solely on larger datasets and more computational resources. Looking toward the future, the research landscape appears poised for developments that mirror the smartphone evolution, moving from specialized tools to integrated platforms. Just as early mobile phones evolved from simple calling devices to sophisticated multi-purpose computers, AI research is transitioning from single-purpose algorithms toward integrated systems that combine multiple techniques. These cohesive systems merge symbolic reasoning with neural networks, reinforcement learning with supervised learning, and local processing with cloud-based computation. The emphasis is shifting towards human-AI collaboration rather than replacement paradigms, recognizing that humans and AI systems have complementary strengths. Privacy-preserving technologies are enabling new partnerships across organizations that were previously impossible due to data-sharing constraints. Meanwhile, sophisticated evaluation methodologies are being developed to keep pace with rapidly advancing capabilities, ensuring that our assessment tools can accurately measure the complex, multifaceted intelligence emerging from these integrated systems. As we conclude today's exploration of the AI research frontier, several key insights emerge from our journey. Current AI systems, despite their impressive capabilities in specific domains, still fall far short of human-level general intelligence. The jagged cognitive profiles revealed by comprehensive assessment highlight both remarkable progress in certain areas and fundamental challenges that remain unresolved. However, the field is making significant strides in creating AI systems that work effectively with humans while maintaining transparency and trustworthiness. From Olympic sports officiating to medical diagnosis, these systems are proving their value as collaborative partners. Privacy-preserving AI technologies are opening new possibilities for collaborative intelligence across organizations and industries previously limited by data-sharing constraints. Most importantly, rigorous evaluation methodologies are essential as systems advance, ensuring we can accurately assess capabilities, limitations, and potential risks. The human-AI partnership emerging from this research will shape the trajectory of intelligent systems for future generations. This research summary was created through AI synthesis using GPT and Claude Sonnet 4 models, with text-to-speech synthesis powered by Deepgram technology and image generation through OpenAI systems. The content underwent human expert review to ensure accuracy and clarity. While we strive for precision in our synthesis of complex research, some oversights may exist. Complete references to all discussed papers are provided in our show notes for those who wish to explore the original research in greater depth. This collaborative approach between artificial intelligence tools and human expertise represents the kind of partnership that defines the future of AI research, leveraging the strengths of both artificial and human intelligence to make complex scientific discoveries accessible to broader audiences. We encourage you to subscribe to AI Frontiers for cutting-edge insights into the rapidly evolving world of artificial intelligence research. Links to all the papers we discussed today can be found in our show notes, allowing you to dive deeper into these fascinating discoveries. Share your thoughts about these developments with our research community online, and let us know what aspects of AI research you'd like us to explore in future episodes. Your voice matters in shaping how these powerful technologies develop and deploy in our world. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.